confirmed. We're safe on Mars.
Maybe you have heard about NASA's Magellan mission to Venus, and you found it amusing, thinking it's the first of its kind. Now is the time to change that belief. Long before NASA dreamt of visiting Venus, the Russians had successfully sent missions to Venus, but the Russian government refused to circulate the discoveries from these missions. But now, no more secrets. Russia's classified images of discoveries on Venus have been revealed and want you to join us. For 20 facts and images about the Venus missions, Venera missions. The facts and discoveries made on Venus are all thanks to Venus missions, which were created purposely for the aim of exploring Venus. There have been a lot of space missions to Venus, but the Venus missions stand out with their data getting better at every launch. And now, we will journey from the beginning of these missions to the end, revealing every discovery made during the mission. Sputnik. Don't be surprised you have heard nothing like this. It was the very first attempt that the Russians made at a flyby probe to Venus. While NASA focused on Mars and other planets, Russians dedicated their time to exploring Venus, and it all began with this mission. That launch kick-started on February 4, 1961, but unfortunately, it didn't leave the Earth's orbit. The Soviet Union had a policy of not announcing details of failed missions, which is why you probably never heard of it. And in fact, it is most times taken off the record that you won't know anything of such ever existed. But what is the reason why this launch failed? While the reason is not clear, it might be because of how the Sputnik, meaning heavy satellite, was built. Though the Sputnik, also known as Venera 1VA, did not fulfill its purpose, it gave scientists insight into what they needed to do to accomplish this mission. Venera 1. Just 8 days after the failed attempt of Sputnik, the Venera missions began properly with Venera 1. It was the first probe in the series of Soviet Venus missions, weighing an impressive 1,400 pounds. In comparison, the Sputnik was a mere featherweight at just 184 pounds. The Venera 1 probe was spin-stabilized and packed with instruments, including a magnetometer, micrometeorite detectors, and Geiger counters. Just like many other probes before it, the interior of the probe was pressurized to just over 1 atmosphere, with nitrogen gas to help the instruments function at a stable temperature. All set, Venera 1 was launched on February 12, 1961, along with an Earth-orbiting launch platform. It was launched towards Venus with the 4th-stage Zond rocket achieving 2 communication sessions in the days right after launch. The first came on February 12 at a distance of 126,300 kilometers, and the second on February 13 at 488,900 kilometers. Normally, the station was expected to transmit every 5 days. And so, on February 17th, which was 5 days after the launch, another communication session took place from 1.89 kilometers. The scientists believed that Venera was in good working condition at the time and were expecting results from it. But that would be the last successful command session, as the one held in the following 5 days was reported as a failure. They waited for the next 5 days, but all they could get were fade-outs. Still, the scientists won't give up on Venera 1 until March 4, when the communication fails eventually. Venera 2. This probe was very similar to Venera 1, but it carried a TV system and scientific instruments. It was not built to make a landing, but just as a flyby, during which it would record information and transmit it back to Earth. On February 27, 1966, the spacecraft passed Venus at a distance of 24,000 kilometers and entered a heliocentric orbit. It started overheating and stopped operating before it could do its job. It is unclear whether Venera 2 failed before or after it was zipped by the distant world. All we know is that it ceased to operate and therefore returned no data. This means there was a need to design more probes. The Soviets designed the next 4 probes, Venera 3, 4, 5, and 6, to more closely study the atmosphere of our hellish neighbor. Generally weighing about 2,000 pounds each, these probes contained a suite of instruments and a detachable pod known as a descent module, equipped with a second collection of devices that included a barometer, a radar altimeter, gas analyzers, and thermometers. But how did these probes do with all of these instruments? Let's find out. Venera 3. Venera 3 was also launched from Sputnik towards the planet Venus, and this time, The mission changed. Venera 3 was designed to land on the Venusian surface, and it was equipped with a radio communication system, scientific instruments, electrical power sources, and medallions bearing the coat of arms of the USSR. Although Venera 3 planned to land on the Venusian surface, it instead slammed into it on March 1, 1966, officially making it the first spacecraft to crash into another planet. However, the communications systems had failed before planetary data could be returned. Although communications had failed, estimates of the impact site put it in an area between 20 degrees north and 30 degrees south latitude and 60 to 80 east longitude. Although Venera 1, 2, and 3 failed, they demonstrated the courage and innovation of the Soviet space program and explored new frontiers in space. The 3 probes eventually paved the way for the later missions that would end up revealing the secrets of Venus. Venera 4. Venera 4 consisted of a 3.5-meter-high main bus carrying a 383-kilogram lander probe with vital instruments encased in a pressure vessel. By June 12, 1967, Venera 4 had been launched from Tiazheli Sputnik. After a mid-course correction on July 29, the probe could enter the night-side Venusian atmosphere on October 18, 1967. Venera 4 was detached from the main bus before it could enter the night-side atmosphere, leaving the main bus keeping a track right behind the probe. Unfortunately, the bus was not designed to survive entry. At an altitude of 52 kilometers, the 2.2-meter drogue parachute was deployed, followed by a 55-meter main parachute. 5 minutes after the separation of the main bus and the probe, the scientific instruments were turned on at an altitude of about 55 kilometers. The instruments were on for 93 minutes, bringing back 23 sets of readings. But it soon reached an altitude of about 25 kilometers, where it succumbed to the atmospheric pressure. Fortunately, we could get information via the probe before it crashed. The probe measured an atmospheric composition of 90 to 95% carbon dioxide. The bus detected no magnetic field or radiation belts and a weak finding of atomic hydrogen at 9,900 kilometers altitude. It was initially believed that the probe had reached the ground, and the measured temperature and pressure represented the surface values on Venus. Though the probe didn't spend more than 93 minutes, it was considered a success for returning data. Venera 5 and Venera 6. These 2 probes can simply be called twins, as they were designed similarly and launched a few days apart. The design was similar to Venera 4, although it was designed stronger to perform better. They also have a main bus with a mass of 1,130 kilograms, which held the descent probes. The probes were designed for high decelerations and were with smaller parachutes in comparison with Venera 4. That was done to allow them to fall faster to get lower in the atmosphere while still operational. The top of the probe would be ejected to deploy the parachute and also expose the instruments to the atmosphere. The scientific instruments in the probe included a radio altimeter, 2 resistance thermometers, an aneroid barometer, 11 gas analyzer cartridges, an ionization densitometer, and photoelectric sensors. Venera 5 was launched on January 5, 1969. A mid-course maneuver occurred on March 14, 1969, after which the probe was released from the bus on May 16, 1969, at a distance of 37,000 kilometers from Venus. As soon as the velocity slowed to 210 meters per second, the parachute deployed and transmissions to Earth began. The probe sent readouts every 45 seconds continuously for 53 minutes before finally succumbing to the temperature and pressure. According to Venera 5, a light level of 250 watts per square meter was detected via the photometer. It also confirmed the high temperatures, pressures, and carbon dioxide composition of the atmosphere found by Venera 4. On January 10, 1969, Venera 6 was launched and the probe was released on May 17, 1969, at 25,000 kilometers from the planet. The probe was able to send back readouts every 45 seconds for 51 minutes and ceased operation due to the temperature and pressure effects at roughly 10 to 12 kilometers of altitude. Unlike Venera 5, its photometer failed to operate, but the atmosphere was sampled at 2 bar and 10 bar pressures. Together, the Venera 5 and 6 probe data allowed a more precise determination of the atmospheric composition. They made it clear that Venus is highly unlikely to host life, dashing the romantic hopes of Venus as an earthly paradise. In summary, they gave an understanding of Venus's pressure in comparison to Earth's sea level, and also gave vertical profiling of the Venusian atmosphere and information about the cloud layers of Venus. 3 probes did not only provide information about Venus, but also had broader implications. They gave scientists crucial information about the greenhouse effect, which you must admit is an interesting topic to scientists. We're not here for the greenhouse effect. Let's move on to the next. Venera 7. On August 17, 1970, Venera 7 was launched, which was followed by 2 mid-course corrections on October 2nd and November 17th. Venera 7 was designed as a lander probe to land on Venus and send data to the Earth. It included an even more ambitious descent module designed to make a soft landing on Venus, which included heavy fortifications so it could briefly survive the inhospitable conditions on the surface. It was allowed to cool to about -8 degrees Celsius before making an atmospheric entry. After aerodynamic braking, the top hatch was blown and the parachute system was deployed at about 60 kilometers altitude. The capsule antenna was extended and signals return commenced. But 6 minutes later, the parachute ripped and eventually collapsed, leaving the probe to fall towards the surface for another 29 minutes. Though the probe impacted on Venus's surface at about 17 meters per second, the signal weakened, pumped back up to its full strength for about 1 second, and then seemingly stopped. The scientists later discovered that the probe had survived the impact, and the weak signal continued for about 23 minutes. It is believed that the spacecraft may have bounced upon impact and come to rest on its side, so the antenna was not pointed toward Earth. Initially, scientists thought that was the end of Venera 7, but it did manage to transmit meaningful data for a short period. For example, the lander measured a surface temperature of almost 900 degrees Fahrenheit, equivalent to 475 Celsius. Yeah, you heard right. It is as hot as a brick pizza oven. Although the probe's pressure sensor failed during descent, researchers were able to use its measurements to estimate a surface pressure of about 92 bars, which is about what you would experience if you were more than a half mile or 900 meters underwater. Now it's time for today's subscribers pick. For years, we had thought that Venus was unapproachable because of its proximity to the Sun. The Russian government had tried to conceal information from the public for so many years for reasons best known to them, and now that the information is leaked, it only sparks curiosity as to what other information they might be hiding from us. Many have speculated that the Russian government is allegedly in contact with the aliens, but as it stands, there is no evidence to prove it. Do you think the Russian government is hiding anything important from us, especially about aliens? Let us know in the comments section. Venera 8. This probe was launched on March 27, 1972. It took Venera 8 117 days to reach Venus with 1 mid-course correction on April 6, 1972. Before reaching Venus, the probe interior was cooled to -15 degrees Celsius. After it entered the atmosphere, the descent speed was reduced from 11 kilometers per second to about 250 meters per second at 67 kilometers altitude by aerobraking. At 50 kilometers, the instruments were turned on and the probe started transmitting data. A decrease in illumination was noted, and wind speeds of less than 1 kilometer per second were measured below 10 kilometers. After landing, it continued to send back data for 63 minutes after landing before failing due to the harsh surface conditions. Venera 8 confirmed the initial data on the high Venus surface temperature and pressure, still stating the same as Venera 7's data. It also measured the light level to check if it was suitable for photography. It was discovered to be similar to the amount of light we have here on Earth on an overcast day with about 1 kilometer of visibility. The first measurements of the surface regolith of Venus were returned, and a profile of the cloud layer, including the detection of sulfuric acid, was made. Although Venera 8 repeated much of the Venera 7 mission, Venera 8's functioning pressure sensor confirmed Venus's oppressive atmosphere and also gave scientists hope of capturing Venusian sites in the future. Venera 9 to Venera 12. This is the point where it all gets super interesting. Of all the Soviet missions to Venus, Venera 9 through Venera 12 is the best remembered to this day. And that's mainly because their landers carried cameras that could directly image the surface, giving us breathtaking images of Earth's hellish sister. Venturing to Venus between 1975 and 1978, several of the cameras on these probes failed, usually due to their lens caps not coming off. Nonetheless, a few of them managed to take and transmit the very first images from the surface of Venus. The early pictures of Venera 9 and 10 are haunting as they were spherically distorted by their wide-angle lenses. They depict a harsh and rocky alien landscape extending out to the horizon. But the images also manage to capture the edges of the landers themselves, which reveals their distinctly Soviet design. Let's take a look at the mission process a little. After Venera 9 was launched on June 8, 1975, it was until October 20 that the descent craft was separated from the orbiter, and landing was made on October 22. A system of circulating fluid was used to pre-cool the lander to minus 60 degrees Celsius and distribute the heat load. This system permitted the operation of the spacecraft for at least 53 minutes after landing. During descent, heat dissipation and deceleration were accomplished sequentially by a protective hemispheric aeroshell heat shield, 3 parachutes, the disc-shaped drag brake, and a landing cushion which absorbed the shock of the 7-meter-per-second impact and held many of the instruments. The panoramic imaging system could only take one 80-degree image instead of the planned 360-degree panorama because one of the 2 covers failed to release. After 53 minutes, the transmission ceased as the orbiter relay passed out of range of the lander. Venera 9 became the first probe to provide images of the Venusian surface. Even though it came in black and white, it revealed a rocky and uneven terrain with flat slabs of rock that appeared to be shaped by volcanic or tectonic activity. The data indicated clouds 30 to 40 kilometers thick with bases at 30 to 35 kilometers altitude, atmospheric constituents including hydrochloride, bromine, and iodine, and successful TV photography showing shadows, no apparent dust in the air, and a variety of 30 to 40 centimeter rocks. A few days later, Venera 10 landed, providing more images that showcased a similarly rocky landscape, adding to the intrigue of the planet's geological history. Both Venera 9 and 10 then confirmed the initial data about the Venusian atmosphere containing carbon dioxide with thick sulfuric acid clouds. They also helped to understand how temperature and pressure vary across different layers, with Venera 9 recording 485 degrees Celsius and a pressure about 90 times that of Earth at sea level. Venera 10 also provided evidence for volcanic activity. Venera 11 and 12 were both launched on September 1978 to provide more understanding of the Venusian atmosphere and its surface. These probes didn't return with images like their predecessors, but they had instruments that were capable of analyzing the surface material, which they did perfectly. After the analysis, they discovered elements like chlorine, bromine, and possibly iodine. There was also evidence of lightning and thunder on Venus, just like it happens here on Earth. But the most intriguing finding was about the twilight phenomenon on Venus. The twilight phenomena of Venus are peculiar aspects visible in proximity to the inferior conjunctions of the planet. They include the refraction image of the sun that has been observed during the planet transits and the extensions observable at greater elongations. Venera 13 and Venera 14. As much as the images of Venera 9 and 10 were exciting, Venera 13 took the glory in no time. Launched on October 30, 1981, Venera 13 and 14 were designed as advanced versions of Venera 9 through 12 probes. They can take pictures and also are equipped with sophisticated acoustic devices that can tune in to the Venusian wind to gauge its speed. Venera 13 sent back color images for the first time in human history, and it led to so many questions that have not been answered. Scientists were left to wonder how the Venusian landscape formed and what volcanic and tectonic tales were the rocks narrating. What do you think about these discoveries? Let us know in the comment section. Venera 13 also took soil samples for analysis using its drilling arm. It was able to drill right into the Venusian surface, analyze the soil, and send back data that made the scientists happy. It revealed traces of minerals and elements, which is another clue to the planet's geological history. It was also able to record sounds from the planet, and these sounds were so unexpected. They are loud whispers that can be amazing and at the same time creepy. The source of the Venera 13 is unavailable for unknown reasons, but be prepared to hear it all on Venera 14. Before then, Venera 13 had more discovery for us. The probe also reconfirmed extreme temperatures on Venus, showing temperatures as high as 457 degrees Celsius, or 855 degrees Fahrenheit. We can just agree that Venus is the Earth's fiery, wild counterpart. Venera 13's gamma-ray spectrometer looking at cosmic rays added to the existing understanding of both Venus and the cosmic environment around it. Scientists also hope to detect quakes on Venus via the seismometers on Venera 13, but unfortunately, no seismic activity was detected during the short time it operated. But you see, they can't get over the fact that they can listen to the sound of another planet. Don't worry, you'll soon share in the experience. Venera 14, identical to Venera 13, also did fantastically well. As it plunged right into the planet, it also sent back colored images that were jaw-dropping. The fact that these probes can give us life and direct pictures of what Venus looks like is just too amazing. On top of that, Venera 14 was equipped with an ATM designed for digging and soil analysis. It took the soil, and after the analysis, the mineralogical data was a good mine shedding light on the planet's volcanic past and its geological activity. Venera 14, like its predecessor, had a lens cap on its camera, and as it prepared to study the surface, the lens cap was removed by pyrotechnic charges. Normally, that was supposed to be a little bit of a problem, but in an unexpected twist of events, it landed precisely where the probe was set to measure the soil's compressibility. The scientists were smart about that error as they used the opportunity to analyze the lens's interaction with the surface. All of these activities were captured in the original audio of the planet. Prepare to hear the amazing songs of our sister planet. The recording you heard was the second time the sound from Venus has been heard. As mentioned earlier, it was first recorded by Venera 13. The played part is the natural sound of Venus, the eerie white noise with a gentle blow of the Venusian wind. The whole of the probe's procedure can be heard from the landing to the time the cap lens was removed, and the mechanical groin of the drilling operation, even to the sounds of the sand being dropped into the analysis chamber. Isn't this just electrifying? Venera 15 and Venera 16. If you thought the images of Venera 13 and 14 were the most beautiful images you have ever seen, then you should meet Venera 15 and 16. The Venera 15, along with its twin, was all about radar mapping. They each weighed just under 9,000 pounds and did not carry landers. The Pioneer 12 probe may have been the first to map Venus using radar, but Venus 15 and 16 did it better. In place of landers, they brought highly advanced radar-based imaging systems that could map the blistering world from elliptical orbits. They were able to reach a resolution of about a mile per pixel. The images returned by these probes were fantastically detailed, revealing broad swaths of the harsh landscape, complete with impact craters, dramatic rises, and lava-flooded basins. This discovery indicates volcanic activity and tectonic activity. The Venusian surface is seen to be altered by objects from outside the planet as well as by forces from within. Impact craters dot the landscape, created by meteorites that pass through the atmosphere and strike the surface. While big craters are rare, small craters are common, but not too small. Those smaller than about 1.5 to 2 kilometers in diameter are not found. Their absence shows that Venus's atmosphere is causing intense frictional heating and strong aerodynamic forces as meteorites plunge through it at high velocities. The future. Although the U.S. made its mark on the exploration of Venus through missions like Pioneer 12 and the wildly successful Magellan, the Soviet Venera program remains the most detailed and intense mission to Venus. Even other craft shown by the European and Japanese space agencies, which have also contributed to our understanding of our planetary neighbor, we still have to give the Venera missions their flowers for their tenacity. And guess what? The Soviet Union is proposing another mission. Meet Venera D, a proposed mission to Venus that would include a highly capable orbiter and a lander. It is set to be launched between 2026 and 2031. It could use some NASA components, including balloons, a sub-satellite for plasma measurements, or a long-lived surface station on the lander. What expectations do you have for the future Venera missions? Let us know in the comment section. Thanks for watching. See you in the next one.